Good evening, everyone, and welcome to this evening's PyLadies event. I'm your host, Vicky, and I'm here with co-host Lay, who you'll see later, as well as our two guests. What we'll start this evening before the talk, normally some announcements. So first of all, I would like to, if I was to scroll up a little bit, I'd like to thank our community partners, Coding Grace for the use of Zoom license, PyLadies, of course, or else we wouldn't have PyLadies Dublin, the PSF, because they cover our fees for Meetup and lots of cool things as well, or else we wouldn't have Python. And then Imagi of Imagi Labs, who gave a talk earlier this year in January, and their discount code should be still good for the rest of this year. I think I don't know if you've seen it before, but I got this on Kickstarter when they came out, so found them free at PyLady. So this is one of the Imagi charms. So you can code Python and make LED lights turn on and off and make animation. So those are our community partners. Thank you again to all of them for making this stream possible as well. So to the main event, we have two speakers. We have Jeffrey, who will be talking to us about using Python to bring physical games to the internet. And we have Pavithra, who will talk about scaling data science with Dask. So these announcement notes will be made available. I'll post them on the Meetup event page, which is this here. And I'll also send a post-event message to everyone, and I'll have a link to these announcement notes. So there's a schedule. We should be on. The event starts, and welcome announcements are happening right now, followed by two talks, and then we will wrap with, if we have time, we'll have some Q&A after the talks. So for anyone who have any questions, please pop them into the chat there on YouTube, and myself and Lay will pass them on to the speakers. And also, do have a chat amongst yourselves as well. The more the merrier. Some announcements. PajamaConf tickets are live. They're online events, and you can watch Python talks in your jammies. It's on December 4th. So check out, the link is pajamas.live. This month is our last event of the year for PyLadies Dublin. We will be back in January, and we are looking for speakers. So if you want to give a talk, a demo, or even a workshop, there's a form that that you can fill out, which is this. I'll have a link to this, and I'll share it in chat after the announcements. If you are interested in giving a talk, a PyLadies next year. And I mention this every month, if you are on this platform called Dev2, which is a dev kind of blogging platform, and there's a few of us on it already. So I'm on it, Chuck is on it, so is Lays. So if you are on it as well, I'm happy to add your name to the list there. Sorry, here. So there's three of us so far that I found. If there's more of you, let me know. It'd be nice to hear you blogging about your dev tools that you're using, or your projects, all fun stuff. And for me, I talk about like diversity in tech and lots of other things that that I wanted to share. As you can see, spoiler alert, I already said that already, that we have no PyLadies next month, because this is the last one of this year. And but we will be back in January 18th. And but don't worry, if you still want to meet other Python people this year, Python Ireland, I think that's the date, their next meetup is a Christmas get together. The details, go check out python.ie or head over to Meetup and look up Python Ireland for their event details. And then for any other events, I have a lot of other events that I tend to curate, and including diversity and tech events, which you can find here. So this evening, there's another Women in Technology Science event for students and UX design. It's a bit of a clash there, but there are other events that are happening for this month. There's a few other, or I think there's a couple more. Awaken Hub and WITS Ireland AGM. So that's it, and the rest of this document is resources for anyone who's interested in learning, do more, trying to find more information about Python and stuff. So I have the beginner section, and then there's post beginner sections, and any other kind of information will be handy for people who want to work on Python projects and feels overwhelmed with the amount of information out there. So if you found something that's really cool, send them on to us at dublin@PyLadies.com, and I'll add it to this resource list for everyone. So you can actually just come here and actually find all the information for relating to Python. So without further ado, I would like to introduce our first speaker, Jeffrey, who will be talking about, sorry for all the bouncing about, this is using Python to bring physical game to the internet. So what I'll do now is I'll put a be right back intermission slide, and get Jeffrey all set up, and we'll be right back. Give me a sec. Where's the be right back? This is what happens live. Keep forgetting things.
Well, hello everybody. I think I should be now on the screen, and everything should be working well. Oh, jumping slides already. Well, I'm delighted to be here at PyLadies Dublin. I watched a few of the live streams over the past few months, and it only felt right when Vicky asked me, could I speak about anything? I thought I'd talk to you tonight about a game I made over the summer that has Python elements into it. I guess a bit of background about me. I've worked for about now 10 years or so in the transportation industry, usually building transportation platforms. So here we have a picture of me visiting some of the hardware we installed in Senegal. And then I think that one's in Galway. It's in the rain in Galway, installing some equipment in the regional bike scheme. So I work mainly doing Java developments across different transportation platforms, sometimes getting to do some low-level C code for some microcontrollers, but it's mainly web applications, all in Java for my day job. Then outside of work, I really like to do lots of different things, and the project I'm going to speak to you about tonight is really a after work for the fun of it sort of project. But to give you a background and type of stuff, I do lots of electronics. I usually do kind of games and sensors and IoT stuff. So on the right here, my house there has become a bit of a monitoring station. I have a couple of different types of air quality sensors that I've made. You can see my weather station there. I have a Stevenson screen. I have all sorts of fun messing around collecting data, contributing to different kind of citizen science projects. I'm a big one for kind of repairs. Up in the top left there is a keyboard older than I am, where I was repairing it for somebody. And then I do a lot of kind of work where I work as a facilitator for different artists, bringing their kind of vision to life on different projects. So that was a smart lighting art display that lit up in a certain way as you walked into a room. Then, yeah, apart from making my own projects, I'm very active in other organizations. So one would be Dublin Maker. So that's a festival myself and other people run each July. Well, we haven't done it physically in a while, but we're virtually this year. Vicky used to be on our team for 2 years. She was our maker advocate and helping spreading the word of making around Dublin and the greater Dublin region. Other groups I'm also involved with is in Engineers Ireland, promoting engineering as a career choice, developing the profession further afield. So I volunteer on their executive board and try and give my 2 cents on the professional organization. And then, of course, TOG, where I usually make all these projects. So TOG is the Hackerspace in Dublin. We've been going about 12 years now. So I'm involved in all sorts of events there, messing around with projects, that sort of stuff. Good, but let's get back to the project that we're here to talk about tonight. So I usually make projects for Dublin Maker. I like to make interactive games, stuff that kids can play with and families. So we're all out in a field and kind of get that real festival vibe. So here are some rough sketches I did back in April time, where I wanted someone to jump up and down and lots of LEDs flashing and have a kind of an old kind of a dance arcade style game where people would interact with. But that was all in the hope that we would have a physical event and we would have people meeting and we could go back to our old 10,000 people on the weekend in Merrion Square and have all that sort of fun. But due to COVID, those kind of projects, the idea of doing a physical project where people could jump around and interact with kind of faded away. So I knew I had to shift the idea to do something that would be able to be played virtually and over the internet. So I first jumped into things that I know, which is LEDs, because I usually put up lots of LEDs around my house for Christmas, so they'll be going up soon. And I usually use this library called Fast LED. It's a great way on Arduino to interact with kind of these addressable LED panels. It's easy enough to write code and animation, and I was very familiar with it. So I knew if I wanted this project to use LEDs, that was my go-to library, and it was fairly easy to use. So within a couple of hours, I had this kind of scrap LED array that I've had in a box for years, and I started kind of prototyping different ideas for a game, and kind of knew fairly straight away that the idea of people jumping on things wouldn't really work remotely. So I decided to, how will I make a game where I could interact with it? So I kind of scaled back my ambition, unfortunately, or fortunately for the event, and tried to make a kind of game where you have kind of like Space Invader style, where you have something coming down towards you on the screen, and you have to knock it off the screen. So in a couple of hours, as I said, it was pretty straightforward to get a quick prototype, and hopefully the video doesn't crash too much with its frame rate there. It'll just keep looping. As you can see, I'm pressing buttons on the bottom. We have streams of light going left and right and up. And the idea is that you would swat away these evil red dots and remove them from the screen and stop them from hitting you as they float down the screen. So that was pretty straightforward to get that up and running in Arduino, but I knew it wasn't the right platform to bring it on the internet, so allow other people to play it. So I did a bit of research and I came across this website here, Remo.tv. So this is a whole kind of telepresence software kit that's made for Raspberry Pi based robots. So it's extremely easy to install, and there's a whole website and allows you to get a quick Raspberry Pi robot up and running on the internet. You have your webcam, you have a mic, you have a speaker, you have kind of all the kind of basic bits of a Raspberry Pi, and enables you to get up and running very quickly and then have a web interface. So, and this all goes to the website, and you can just give the users a link and they can interact with it. So I pulled up some examples of other robots on this platform. So the one on the left is a chicken coop, which I took the screenshot about 2 or 3 hours ago. And you could move the camera around, and you could press a button to drop feed for the chickens, and you can see them nibble away. And you could, and there's other robots where it allows you to drive them around. I didn't get to play the one on the right, but it sounds very interesting, and I know Vicky might like it as well, which is a cat petter robot. So I just took a screenshot of the Twitter post about it. It's a robot you could go and control, giving pets to this very appreciative cat over here. So this platform allows people to get very creative. The term robots is very loose. It's really kind of an internet control device that anyone can expand and get up and running. So I'll let you see now how I expanded and how I used the program, and how easy it was to get my physical game with all my LEDs onto the internet. So this is my prototype, my very, must give that, very dusty desk there, which is just a straightforward Raspberry Pi. I had hooked up 2 LEDs. I didn't have a Pi camera, so I used the webcam that is viewing me right now, and I just plugged that into the USB port on the Raspberry Pi. And with, I think, 2 lines of an edit on the basic script that comes with it, allowed me to very quickly, this video here is playing here. So this is a screenshot of the website where I'm pressing A and D on my laptop. And it's a fairly quick, short delay where it then lights up the individual LEDs. So then I was quick to see that this was the platform that I could use to make my game for everyone to play. So if I jump back and show you a bit of the hardware and what I had in mind here. So we had our Arduino on one side that was talking to I went and got a bigger LED display. So it was 32 by 32, so a lot more LEDs. And then I have my Raspberry Pi here. And to keep things simple, I just used a few pins where they would generate interrupts on the Arduino itself. So simple pins assigned to one to start the game, one for left, one for right, and one for up. So very simple control. No, of course, the Python package supports sending serial messages and more complicated messages back and forth between the 2 devices. It has lots of kind of sample scripts for example, using the Raspberry Pi motor hat, or using lots of different Adafruit boards. All the code is all there, but I kind of kept it simple and just had a few pins that I would set high and low. So here is a picture of what the hardware looks like. So we're a bit switch around. So we have a Raspberry Pi, we have a logic level shifter. So you might or might not know. So the Raspberry Pi talks 3.3 volts logic. That particular Arduino talks 5 volt logic. So we need a special chip to help them chat to each other. So it's a very kind of straightforward. And now I guess because it's a Python meetup, we'll jump to the actual code now itself. And to disappoint people, it's very small amount of code and a very small amount of Python. Pretty much the framework really does it all for you. So we just have main method move here, because remember, it's about a robot usually, so it's about moving. We have letters that it just does an if and else chain to look for. I added sound effects to my project. So I just did a simple calling a play and calling the sound effect I wanted. You can see I had different ones for side, right, and up. And then the send interrupt, all it would do was pull a Raspberry Pi pin high, wait a very short amount of time, and pull it low. So it's very simple Python codes to talk to the Arduino itself. And now I'm going to jump to what I had to do on the server side. And you can see it's even, it's just as easy. Where I go to my page, once I create an account on the website, it would give me a simple file to edit on screen. And you can see the label. So that's what appears in the screen. The command. So this is the letters it sends to the Arduino. So we have one, see the label for up. So it would show up. It would send U to the Arduino, and the hotkey, so that's a person on their keyboard, could press the W button, and it would then send the up command. So then this is a bit of testing here. So the LEDs didn't really work in the daytime. So there are my lovely bird bed sheets my mother bought me all around this LED project, trying to get it some darkness. The picture on the light there is me demoing it underneath those sheets. Left it on for a couple of days, got a few people to test it out. Excuse me. So then Dublin Maker came around. This is the project here down in my living room. My laptop on the table there is just to test it. And I used my brother's easel there to hold the webcam. And yeah, that ran pretty much flawlessly for the couple of days of Dublin Maker. It was interesting. I'd be sitting, so this is about half my living room covered in black bags, all taped over. And you'd be sitting there and see people, the flashing lights and people playing the game. And yeah, so I did the project for Dublin Maker. I also want to do it for Maker for Rome, bigger event, longer period of time. And one of the downsides of the event, one of the downsides of this setup was no one can see what was going on. It would just be the black figure, the darkness there on the right, where you couldn't really see what's going on. So I got this brainwave of adding a smart plug to it, and using the Python script, the Python library for this particular smart plug. The more went into really signing up to the developer license, getting an API key, all that sort of stuff for it. Then the actual coding. The coding is, I pretty much copied it from the example, put in the IP address of the smart plug, I put in the API key and copied the generic code from it. And it was very simple to have the plug then turning on and off and having that as another option for people playing the game remotely. So I think I'm running out a bit of time, so I'll try and speed things up a bit here. This is my living room, as I said, being taken over, covered everything with black bin bags to kind of darken the room. For the next event, because I knew I was turning on a lamp, I tried to make it a bit more visually appealing. I stuck up a lamp there, stuck up a nice plant, put a duck in the background, is always good to have for any sort of tog project. And so that was what the view people would see. And so we're going to now jump onto a bit of gameplay. So this is the screen people would see as they're playing the game. You can see there I'm pressing up and the lights had come up, and then you can press left and right. And I'll quickly show a different video here while I manage to Alt-Tab here and randomly press it. And maybe you'll... Okay, so we have a lot of flashing lights. So this video is like 7 minutes long. I think it was the longest I ever managed to... Pause it there. This is the longest I ever managed to play it without losing there. I lost my spot. There, pause. Perfect. Yeah, so I just wanted to pause on this screen. This is when I turned on the smart plug. You can see there at the bottom of the screen, turn on light to see project. So it was a way for people to see the inside of your project, because that's really my main motivation for doing all these projects, is to get people interested in the educational aspects of it, and that sort of stuff. So I will just end on, if you want to see more game footage, I will give Vicky the links to the YouTube videos so you can watch the 7 minutes or something, or a couple of different videos of me trying to play the game and win it. It just gets harder and harder. The game speeds up, but I'll give Vicky the links and you can certainly watch it and see what the game is like. And then just to end on it, that of course, if my tabs and next slide button is stuck because of the video. Anyway, I have plenty of links to, because now it works. So I have plenty of links to the different open source projects I used, because without their codes, my, I think it was 79 line Python application, I'm sure would have been much more complicated to handle all the real-time video interactive links. Would have been much harder without the work that these people have done before me. So thanks very much. If you stick your questions in the comments, we'll do our best to answer them. And I'll hand it back over to you, Vicky.
Awesome. So hi everybody, and welcome to Scaling Data Science with Dask. And thanks, Jeffrey. That was a wonderful presentation right before this one. I absolutely loved it. And I'll chat more about that later. So I'll start with, my introduction, tell you who I am. I am Pavithra, and I'm joining from India. It's past midnight here, almost. And I work as a data science evangelist at Coiled. Coiled it's a platform that helps you scale your Dask workflows to the cloud. But today's talk is just about Dask. Coiled, we can talk about it later. I also, in my spare time, try to contribute to some open source projects, including Bokeh and some projects at the Wikimedia Foundation. I recently graduated with a bachelor's in computer science. And on the internet, you can find me at Pavithra ES. That's my handle across Twitter, GitHub, LinkedIn, anywhere. If you have questions or anything, you can let me know there. And my work email, I have mentioned that here as well. So now let's get started. This slide, all the material, the slides, the notebooks I'll be using, everything is available on this bit.ly link. It's bit.ly/PyLadies Dublin Dask. You can go and check it out there. But I mean, if you want to follow along, you can. This is more of like just a talk. So I would encourage you to just, sit back, relax, and just take it all in. Okay. I wanted to start with a question. What's your experience with scalable data science? Just to, gauge how much you've worked with Dask before or scalable compute before. I have the chat open, so you can let me know there. But for this session, I think I'm gonna move over. I'll just assume a beginner to intermediate level. Because it's a live stream, I wasn't expecting that. That's why the slide is here. But yeah, if you could let me know, it'll be good. I can tweak things as we go along. Here's what we'll be discussing in the next 30 minutes. First, we will start with the PyData ecosystem. We are at PyLadies. All of us love Python, and PyData is a big part of why Python is so popular in the data science community, right? So we'll see why PyData is so awesome and some limitations it might have. Next, we will start with some pandas computation. I have a feeling most folks who are interested in data science and Python are most familiar with this library. So we'll start there, and we'll work with about 1 gig of data. Then I'll introduce Dask. We'll talk about what it is, why it's important, how you can use it, all of that. And then we'll use Dask to perform some compute on your own laptop with almost 50 gigabytes of data. And then we'll move that over to the cloud. We'll use Dask again on the cloud, and we'll jump to 1 terabyte of data. So 1 gig to 50 gigs to 1 terabyte, like that's a big jump. And we'll do all of that from our own laptops. And lastly, we'll build some intuition around Dask. So I feel that's the most important part of this talk, and we'll spend a lot of time there just to understand what Dask is about and how it fits in, and how to wrap your head around it, and how you can just go in and do what you actually want to do. So yeah, let's get started with pandas. So I said 1 GB data set. Let's jump into the Jupyter notebook. Here I have this notebook. If you go to the bit.ly link, you should find this in the PyLadies Dublin folder. This is the demo.ipy notebook. All the data I am using here has been created in this other notebook called Create Data, and it's been created with Dask. So at the end, if we have time and if you want to go through it, we can. So today, for now, we'll look at demo, and we're starting with pandas. I'm importing pandas, okay, and I am reading this 1 gig-ish data. And this data is in the Parquet file format. If that's a file format you're not familiar with, you can go and check it out. There's a lot of resources. Coiled has also written a bunch about it. It's just a lot more optimized than CSV data, especially when you're scaling to large workloads. It's a lot nicer to use Parquet. It has better compression. It is columnar. Has a lot of advantages. All right. So pandas reading Parquet. Just looking at the first few elements. So we can see it's a time series data set. It has ID, name, X, and Y. These are the columns. And I'm doing a simple pandas compute. I'm just calculating the sum across a column of this data set. And I get the result. This looks fine. I did this compute on my laptop. If you're opening this with Binder, like in the link I shared, there is an option to open this with Binder. I don't think Binder will be able to handle 900 megabytes of data, because Binder provides, I think it's about 2 gigs of memory, which is not enough for this. But if you're doing this locally, you should be able to run this pretty comfortably. Okay, so that worked, all good, all fine. Now, if I scale this to 50 gigs of data, I will see a kernel restart error. If this were CSV, I will see a memory error, right? So why does this happen? This is because pandas can only work with data that fits on your local RAM, right? And in fact, there is this pandas rule of thumb that Wes McKinney, I hope all of you have heard about Wes McKinney. He's the author of Python for Data Analysis. It is one of the most popular books for data science in Python. Wes McKinney says, have up to 5 to 10 times as much RAM as the size of your data set when you're working with pandas. So I have about 16 gigs of RAM on my machine. That even if I take the 10 times number, it's 1.6 gigs. That's the optimal amount of data I should be processing with pandas on my computer, right? And this also, it was a 2017 post, so it's been a while since then. So this is the latest rule of thumb I could find. If you have a better rule of thumb, please let me know. But you can see that the Panda zone is quite small compared to your RAM or your hard disk. Hard disk has a lot of storage. Okay. Another thing here is Pandas is single core, which means it can leverage only one of the cores in your CPU, and modern computers have a lot of cores, right? We hear quad core almost every day. My own system probably has 6 to 8 cores. So it'll be nice if we could use all of these cores. And that's where Dask comes in. So now, what is Dask? A lot of text, but we'll break it down later. I'll just read this out once completely. So Dask is an open source library for parallel and distributed computing in Python that follows the familiar syntax of the existing PyData ecosystem. So yeah, a lot of buzzwords. So we can break it down one by one. First is open source. Yes, Dask is open source. You can go to GitHub, find the source code, you can contribute, file issues, do whatever, right? And the entire community has the Python open source culture, which I personally love. Next is parallel and distributed computing. As promised in the abstract of my talk, we will dive into parallel distributed computing. Let's understand what that actually means. Parallel computing. I showed you the core diagram before. When you use all of these cores, you can compute on all of them in parallel. This is parallel computing. Right? Yeah, that's what it is. So you're working in parallel using all the cores, multiple processes, and shared memory. So this entire parallel computing, every time I am using parallel computing, I mean on one machine that has one RAM, right? Like it has one place where all the data is stored. Now, and when we talk about distributed computing, we think about many machines, and each of these machines have their own CPUs and memories, and each of those CPUs will have multiple cores, and all of these can interact with each other. So this is what is a distributed compute, and you can leverage this entire network to do your computation, which means you have so many resources. This is a lot more than a single computer, right? So this is what parallel distributed computing means, and Dask helps us leverage this paradigm. Next is it follows a familiar syntax. So Dask was built by Pythonistas for Pythonistas, right? And one of the goals of the creators was they didn't want to invent anything new. So any Python data scientist working with the tools they will find it pretty familiar. And I'll show you an example. So this on the left, this is scikit-learn call. On the right, this is Dask ML. Right? That's the only change I've made. And the right one that uses Dask can scale. So this is what I mean by familiar syntax. Like anything you use, Pandas or NumPy, you're going to find that familiarity with Dask. And lastly, the PyData ecosystem. So this is the best part about Dask, personally. Okay, second best. I'll tell you my favorite part about Dask later. So the PyData ecosystem is amazing. As I said, this is the reason why when I today think about data science, I think about Python. Right? It's because of all of these tools, which are great. And we all love them and we use them, right? But it did not traditionally scale. And all these scalable tools that we have, like the traditional scalable tools, Spark, MPI, they are not Python native. So there is friction between the Python libraries and these scalable tools. So Dask was built to serve as that parallel computing tool for the Python ecosystem. And today, the Python ecosystem is scalable because everything you see on the screen is built on top of Dask and can scale, right? So yes, now we've sort of understood what Dask is and broken things down. Now let's see it in action on the 50 gigs of data that I couldn't operate on with Pandas. I'm going to use Dask for that. Okay, so here I'll be using Dask data frame. So this is an introductory talk. I'm not going to go into much detail code-wise, but just for reference, Dask data frame is the API, is the Dask API that is used to scale pandas code. Okay, so I'm going to import Dask data frame, and I'll be starting a Dask cluster. So this is the syntax to do that. Let's run this. Okay, there, and here we have the Dask client. So this is my favorite part about Dask. That is these dashboards. Let's open up a few, shall we? Let's open the cluster map because it's amazing. Task stream and the progress bar. Open this. Let's put that here. Maybe if there's space. Okay. All right. Let's see how that goes. So Dask distributed. I'm just going to keep it simple and Dask. It has this. It comes with the dashboard that lets you just see what's going on when you're using or doing any compute with Dask. And now I'm going to read that 50 gigs of data that I could not read with pandas. Here, that's it. And there, head shows me the first 5 elements. And then I'm going to do the same compute of calculating the sum of one column. And with Dask, I need to call compute because that's how Dask works. Before I call this, no actual computation has taken place. Okay, once I do this, you can see things happening on the right. Yeah, there, Dask is computing on my machine, which has 16 gigs of RAM. I won't let this go on and on. Let's go back to the slides. But if you're doing this locally, you can watch it. So sorry, coming back. Right. So with 50 gigs, that was great. And with this itself shows us how I or any data scientist can use Dask in their regular workflow. But to take this a step further, how about working on a terabyte of data? So this is a big leap from 50 gigs. The 50 gig data set was still local. Like I had that locally on my storage hard disk, but its capacity is 500 gigs. There is no way I'll be able to even store 1 terabyte of data on my machine, right? And Dask local it's not going to help me anymore. So I either need a bigger computer. Like if I could store this data locally, I can just do the same thing I just did, or I can leverage cloud resources. So that's where Dask in the cloud comes in. And we'll be working with 1 terabyte of data. I'll go back to the notebook. So this compute has completed. I'm going to close this Dask client. So for Dask on the cloud, I'm using Coil here, but you don't have to. There are a lot of Dask open source solutions. If you go to the Dask documentation, you can find a ton. But disclaimer, I work at Coil. That's the reason I'm using it. And also, honestly, it's one of the easier ways to deploy Dask on the cloud. So I'm just going to import Coil and creating a bigger cluster, just asking Coil for more machines. I started this cluster earlier. That's why I have it right now, but usually it might take up to 2 minutes. And connecting it to Dask, right? I'd have a warning here, nothing big. It just says some versions don't match. But now let me go and connect my dashboard as well. So now this is Dask running on a distributed set of machines. Like I showed you the distributed diagram of a network of machines on AWS. So none of the all the compute you see henceforth is happening on the cloud. The data itself is stored on the cloud. So the 1 terabyte data, I told you I can't keep it on my laptop. So I have put it up on an Amazon S3 bucket. Okay, so I'm going to use Dask to read it. Same syntax, nothing else has changed. That'll take about a few seconds. I'm just going to run these so that I can keep talking. Okay. And you can see here in this diagram called the cluster map, the number of workers we have. Initially, we had 4 because I was running Dask locally. Now, because I have 20 machines, it's showing me 20 workers. let's stay on this slide. So the whole idea in this first exercise is to just show you what Dask can do, right? I could go from 1 GB to 50 to 1 terabyte, all from the same notebook on my laptop here. So this is pretty powerful. And there, so head is done. Now I'm waiting for the sum to start to show all the computers coming online. Yeah, there you go. So that's all the cores of all my machines. So I have 20 machines, each with 4 cores. So yeah, that's how many lines I have here. And it's computing, and it'll just go on. We can go back. Okay, so we had some pandas rules of thumb, showing you some Dask rules of thumb. So the first rule of Dask in the Dask community, and I think it's widely accepted, is to not use Dask. Like, yeah, the first rule of Dask is don't use Dask. Anytime you move from a normal data science workflow to a distributed or scalable workflow, there are going to be challenges somewhere or the other. So if you can use pandas, just use pandas. It's amazing. As we said, it's an amazing library. All of us use it, and so many people love it for a reason, right? So if it fits in memory, like if it agrees with the pandas rule of thumb that we learned about earlier, just stay with it. There is no reason to look at anything else. But if you have a large amount of data that fits on your machine somewhere, it's better to use Dask localhost that I showed you with the 50 gigs of data. And if your data is on the cloud in the first place, you might as well just use Dask on the cloud in any way you like. Because just bringing the data from the cloud to your laptop is going to be expensive and it's going to take up time. Might as well do the compute where the data is, right? So yeah, with that, we're at the end of the first part where I tell you all about Dask and just show you the power of Dask and Dask in the cloud. Now, this second part is about building intuition around how Dask works. So welcome to Dask Car 2020. So this is an analogy we'll be using of a race car to understand how Dask works. So you can think of it as 2 different things. First are race cars that Dask provides for you. And second, each of these race cars has an engine, right? You can also use that engine separately. So this is what Dask was initially meant to do. So Dask Array and Dask Data Frame are race cars that help you scale your NumPy and Pandas code, right? And we have another one, DaskML for scikit-learn. So the Dask creators, they wanted to give people these race cars, like as Dask Data Frame, and hoping they'll use it. And a lot of people did. But as Matthew Rocklin, he's the creator, one of the original creators of Dask, says in this video that this is a very good video. You should check it out when you get the chance. I have linked to it. You can find it in the slides. Said, it is as though we built a nice car and everyone wanted the engine. So personally, I think this is the beauty of open source. This is the beauty of the Python community. Like, we are just all tinkerers, and people wanted the engine, and they took the engine and built things on top of it, and it's amazing. So we have the Dask Data Frame race car, which consists of the Dask engine and pandas, right? You can take the engine and build whatever you want on top of it. That's what Prefect did. Prefect is a workflow orchestration tool, which is built on top of the Dask engine, right? And in fact, most of the Dask usage today is indirect. By indirect, I mean this tool is built on top of Dask. And people don't realize that they are using Dask when they are using PyTorch, for example, if you've used that before, or Rapids. It's a GPU acceleration tool, all built on top of the Dask engine. So yeah, this is the overall analogy I wanted to share with everybody, and our compute should be over by now. Oh, almost. Yeah, there you go. We have the result in that time. And I'll close this because that's good practice with Dask. yeah, that brings me to the end of this talk. And lastly, I also wanted to share this big slide. This shows everywhere Dask is used today, right? It's used in machine learning. It's used for forecasting, for image processing by all of these different nonprofit organizations, for-profit organizations, everybody. Yes. Now I'm going to open for questions. And if you want to learn more about Dask, you can go to Dask documentation. And this is the dask.org page. I have a link to it. Yes, it's linked in these slides. Yeah, do we have any questions? We haven't even like scratched the surface of Dask, but that was my idea with this talk, to just give an analogy, just show you what Dask can do. And if you're interested, you can go and learn more, or you can hit me up on Twitter, anywhere. Happy to talk about it.
Yeah, we do have one question. It's from
Jeffrey. Jeffrey, do you want to ask it since you're here?
Sure, yeah, I can ask it. And my main question is, you switched to using the distributed or in the cloud one on the AWS. How does it handle multi-users? Are all the jobs kind of round robin, or is it first in, first out sort of mechanism?
I want to break your question down a little bit. Do you mean all the jobs between the workers, like this one computation, or do you mean if you're giving it multiple operations, how does it handle it?
So say you want to use the cluster and your coworker wants to use the cluster. Are you using the same one? Is there a scheduling system between it?
If you're using coiled, you can give everyone separate machines, like a different cluster they can work with. So yeah, it depends. If you want to have a shared cluster, you can set that up with the Dask open source tools, like, going and doing it yourself. But how coiled works is it gives all of you separate ones. In fact, there should be a team page. I don't have access to it now, but you can see all your team members here and the things they're running, which is pretty cool. Yeah.
Cool. Any other questions? I think just want to mention a comment from Andrea saying that you like that the first rule of Dask is don't use Dask. But yeah, it was great. Especially like you just left a demo running, left your code running in the background as you gave a talk and just came back to it. It was like all timed perfectly.
I know. I wasn't expecting it to work that well, but I'm glad it did.
Oh, you spoiled it now. It's magic. But yeah, it's fantastic. Thank you for your talk, and thank you, Jeffrey. So so if anyone have any questions, just pop it on. If not, I think we're okay to wrap up early as well. I think we're only a few minutes to go. I will get the links from all the speakers. And then I'll post about to everyone. And if there's any specific questions you have that you thought of afterwards and go, oh no, I need to ask, just drop us an email at dublin@pyladies.com and I'll pass it on to speakers. Same with any other speakers in the past. If there's any questions that you've seen in past videos and you really want to ask and you want to get in contact with our speakers, just let us know and we will pass those questions along or to those speakers as well. So I think Andrea was saying like a great talk, really like dare to demo. I think the demo gods, we all know. But it is fantastic. Thank you again. I'd like to thank you, Leigh, for helping out, for moderating and being co-host, making sure everything is working. Thank you to our speakers, Jeffrey and Pavithra, and thank you to everyone who joined us this evening. It was really great, and for anyone who is watching the playbacks as well. So this will be all on our playlist for this year, so do feel free to. I really have to do this more often, right? I really have to get people to hit that like button and subscribe, the usual streamer thing. I know Jeffrey's laughing, but it's nice to know that that we can keep doing these kind of virtual events. I know we possibly next year we will have some in person, but we haven't planned. We're kind of planning, but at the moment, just it will be mostly remote right now, especially given the recent numbers and stuff. So we like to make sure everyone is safe. But if anyone still wants to give a talk, even if we're doing in person, you still want to give a talk virtually, that is also great, because that'll be a hybrid event. So that just gives me another challenge to figure out how to do that. So that's all good with me. So yeah, so I will say good evening to everyone, and thank you for joining us. Again, thanks to our community partners as well, Coding Grace, the PSF, PyLadies, and Imagulabs. And but yeah, if you are interested in speaking next year, I'll send a form around, and please do. It can be 5 minutes, 10 minutes, half an hour. But thank you again, and I wish you all a good evening. Bye.